Now here's a list of all the things I've made so far. I'm not going to read the list. You can look at them if you want. They're all simple, single functional groups. You know what I mean? I mean, some of them are esters. It's kind of a double. But anyways, they're mostly simple things with single functional groups on them that I made. And there are no more really single functional groups left, except for one, aldehyde. Aldehydes are hard to make. I mean, don't get me wrong, I can make one. I have the stuff to do it. But they're all like, you know, chromo chloride, pyrididium, wait a second, what is it? PCP, whatever that is. Pyrididium, chloro, whatever, or KCC. You know, but see, the thing is all of those oxidizers are based on chromium. They're based on chromate, you know, dichromate, whatever you want to call it, chromic acid. They're all based on that same thing. And for me to make that from scratch, I mean, I can only make about 20 grams at a time, and it takes like the whole day. And, you know, the molecular weight of it, you know, the molar mass so big, you know, that you need 20 grams is nothing. Just to have more of this stuff, you need like, you know, 250, 300, I don't know what the molar mass is, but you need a lot of it, you know what I mean? And that's just to make the dichromate. I mean, then you have to change the dichromate into, you know, the PCC. It's pyrididium chlorochromate, PCC, or potassium chlorochromate, which is a little better, I think. So much stink. Then you have to make the pyrididium. You have to, you know what I mean? You have to make chromochloride, whatever you're going to use for your oxidizer. It's going to take another day. So now it's like, and you only get a little bit. You know what I mean? That's why I don't like that. I need another mild oxidizer. And they're all nasty except for the KCC, I guess. But PCC, or I gotta look that up. Pyrididium jeez. Anyways, they're all nasty chemicals or whatever. So if you noticed my last experiment from last year, I tried to make a set of aldehyde. I did make 8 milliliters, and then the second time I did it, I doubled my yield because I used half as much ethanol, and I got 8 milliliters again. So I have made it, but it was a crappy yield. I mean, I started out with 400 milliliters of ethanol in the first one, and 200 milliliters of ethanol in the second one. To get 8 milliliters each time, that's not good. So keep in mind, these equations aren't balanced or anything. But I figured it out. The first 2 times, like I said, I got 8 milliliters doing this with the copper and the ethanol. And the first 2 times it worked, and I tried to tweak it, and I tweaked it the wrong way, so I kept getting worse and worse. So this time I know what to do, tweak it the other way. Plus I bought more equipment so I can have a better control over the temperature instead of just guessing and throwing a whole bunch of heat on there and hoping it's, you know, going right. So if I figure that out, I can make a set of aldehyde from ethanol, or if you take the red part off, I can make formaldehyde from methanol. Now the way I think that I figured it out is to this trioxane. I'm going to distill it, purify it, and throw it in some water with a little bit of protons like sulfuric acid. And that should make formalin, which is basically just formaldehyde in water. Then to prove it, that's what I made, I'm going to mix it up with some ammonium chloride and some water and make some methylamine and see if it really is formalin. Then I'm going to take some hexamine, some ammonium chloride and water, and you don't even need ammonium chloride, you just need water. But I'm going to add a little bit in because the more you have in there, the better it is. And try to make methylamine. I don't have it in the equation there, but I would use hydrochloric acid to hydrolyze the hexamine into formaldehyde and ammonium chloride. Another thing is I'm going to take some phosphates, mix it with some silicon dioxide and some carbon. It's kind of like a thermite reaction, but instead of getting a metal from an oxide, you're getting a metal oxide. You're getting a phosphorus from a phosphorus oxide, and you can make white phosphorus with that. And then I'm going to take the white phosphorus, and you can either heat it up to 250 C or give it some really short wavelength light. I bought a 204 nanometer wavelength light. So I'm going to heat up the white phosphorus, you know what I mean? It'll be in water. It's more dense than water, so it'll be on the bottom. And I'll just heat it up to about 45-50 degrees Celsius so that it turns into a liquid. I'll shine my light on it, and as the red phosphorus is made, it should fall down to the bottom as a solid. And when all the white phosphorus is gone, you know, it'll all be red phosphorus. And I'm going to take some toluene again with the light. I bought a light that's orange. Instead of 204 nanometers, I can't remember what it is. Maybe it's 520, I don't know, I can't remember. But it's orange light. It's good enough to break the bromine-bromine bond, but not strong enough to break this bromine-carbon bond. That's an important part. You don't just use UV light. You use the appropriate amount of light. And I'm going to make my benzyl bromide. And I'm going to do three reactions with benzyl bromide. I'm going to do one to make benzyl alcohol using the potassium nitrate. I'm going to use the same basic thing, but kind of different heat and different ratios. So I'm going to make benzaldehyde. And I'm just going to use sodium hydroxide to make the benzyl alcohol, just like up here, but with no potassium nitrate. It takes forever. It's like a 30-hour thing. But I want to see, you know, you got to try out every experiment. And keep in mind, if I can make the formaldehyde up here and the acetaldehyde, then I'll be making benzaldehyde with 3 aldehydes. So I'll make some esters, benzoic acid, and ethanol. These are acetic acid and alcohols to make these appropriate esters. That's pyruvic acid and ethanol to make this ester. And I've made esters before, so my yield should better be at least, you know, it should be like 85 or up percent yield. But we'll see. And then I also want to hydrolyze these. Once I make them, I want to hydrolyze them back into the carboxylic acid and the alcohol. Not least, bleach oxidation. Like I was saying before, to make a aldehyde, always usually relies on a oxidizer that is based on chromium. And I don't like those oxidizers. So I'm trying bleach. The actual oxidizer is hypochlorous acid, but you make it by, you know, adding them together. I've done this experiment, so I know I'm going to put this up on the video, definitely. Because I did it like 10 times. You can't make an aldehyde. You can make an aldehyde doing this, but you need a catalyst. And I don't know how to make the catalyst right now or get it, or I don't want to do it because it's a big giant molecule. If anyone wants to know the name of it, I'll give it to you. But you can make, you know, you can just use methanol or ethanol and make the appropriate aldehyde. But you need that. You get really high yields, but you need that that catalyst. Because even with making it with a secondary alcohol to make a ketone instead of an aldehyde, I only get like about 40% yield, although I'm still playing with it, trying to tweak it. But I'm sure if I had that catalyst, that would give me even higher yield than 40%. And then I went to, since I'm making methylamine, I want to try to add it to some carbonyl groups. So I'm going to add it to this ester that we made in the last thing up here. And this one right here. Now, I have, you know, I jump around. It's like I have ADD or whatever. So this is just my plan. Doesn't mean this is what's going to happen. Or, you know what I mean? I might go off on a tangent and do some other stuff and this. But just to give you a little heads up, because I probably will put up at least a couple videos. Definitely the acetaldehyde from copper. Definitely this one. But I did at least 10 experiments on each one. So I think I got at least some of it down. Definitely can put it in the video. Anyway, it was all a great day. And science is great.